Hi everybody, my name is Efe Demir Özkan. I am a freshman in Bilkent University in Department of Biology, Molecular Biology and Genetics. I will present my Physics 101 experiment today. My experiment's name that factors that affect the fluid resistance. In this experiment, I'll aim to see what are the different things that affects the fluid resistance. I look into the 4 different factors in this experiment, one of which is weight, second one is cross-section area of the objects, and third one is the shape of the object, and fourth one is being the density of the fluid. For the first part of the experiment, I look into the factor of weight. I use the same object as for 3 of the falls, but I changed the weight by using dishwashers. I basically multiplied the weight by 2 and 3 factors of the initial weight. As you can see, I'm dropping the same object from the height of 2.2 meters. The time for this fall measured with the video's frames. Each video has a 60 frames per second setting, so I can calculate a precision of 1 of 60 of a 1 second. For the second part of the experiment, I look at the surface area. We have 3 different objects with different areas. Largest one has a 8 by 8 area, as the middle one has a 6 by 6 centimeters area, and smallest one has a 4 by 4 centimeters area. All of the objects have the same weight and have the same shape. Therefore, just the surface area changing in this experiment. When it comes to the results of the second experiment, we can say surface area is affecting the fluid resistance in general. We can see that large surface area has the slowest fall, and the small surface area has the fastest fall. We see a difference at their fall time. Largest surface area object with the largest surface area has a fall time of 44 frames, and middle one have a 43 frames, and smaller one have a 41 frames of fall time. For the third part of the experiment, I look into the factor of shape, and I use this cup for the different shape. I dropped it for 3 times, and every time I change its direction. One time I drop like this as a pyramid, and second time I dropped it this way as a little bit of parachute, and third time I blocked this part, the hollow part, with the tape, and I dropped this way. As always, I dropped at the height of 2.2 meters. When it comes to the results of the third part of the project, I can say shape has a significant impact on the fluid resistance, and we can see that by difference between the fall times. And I can say the fastest shape is this one. This indicates this is have the less air resistance on the when it's dropping. This object's fall time is 40 frames. The second one comes from this shape with blocked phase. It's 33 frames of a fall time it have, and the slowest one is the little parachute shape. We did it with the without the protection. It's fall for 45 frames. For the fourth part of the experiment, I look into the fluid resistance, the effect of the fluid density on the fluid resistance. I tried three different fluids, one of which is air, second one is isopropyl alcohol or rubbing alcohol, and third one is the water. I chose this fluids because first they are easy to come with, and second one is they have a significant difference between the density of them. As an object, I use this ball bearing because it was easy to drop into a tank of fluid. Yeah. As you can see, I'm dropping the same ball bearing and in the different liquids. The height I set is 16.5 centimeters. For the fourth part of the experiment, results shows that fluid density has an effect on the fluid resistance. The three of the different liquids we tried, air is the less dense of them, all of them. Because of that, when ball bearing drop from into the air, the fall time is the smallest one, being the 12 frames. When it drops to isopropyl alcohol, the medium dense liquid fluid, the drop time is 13 frames, and the water, being the most dense, has a 16 frames of fall time. This shows that densities affects the fluid resistance.